So good afternoon, everyone, and welcome to the Smart Inspection for Industry 4.0 webinar. This event is brought to you by OCP Maintenance Solutions in collaboration with Airbus Instruments. I'm Sarah Khadim, and I represent OCP Maintenance Solutions. I'm an IT technical lead and business developer. I'm also joined here today by my colleague Shaheen. He's also an IT lead, and he's specialized in hardware development. Hi, Shaheen.
Hi, Sarah.
So I'm also in charge of developing key partnerships with leaders in the industry, and one of our partners is Airbus Instruments, who is with us today. So I'm joined by Mr. David Howard, the Chief Executive Officer of Airbus Instruments. David, can you hear me? Yeah, I think he's going to join us in a couple of minutes. Yeah, David is here. Hello, David. Hi. Okay, so as I was saying, David is the Chief Executive Officer of Airbus Instruments, one of our key partners. Thank you for your time, David, and welcome again to this event. So I would also like to thank our audience for making us part of you today. As you know, this is a live event, so please do submit questions for our speaker. At the end of the program, we will address as many as possible. We're going to have a Q&A chat box where you can interact with us, and we're counting on your interactions. And of course, questions are welcomed in French as well, as we might have a French discussion by the end of this webinar. So due to time limitation, those that aren't answered at the end will be followed up via email. And we have included here contact information that you can use in order to contact us. We're going to send them to you later on. So let's get started. So about today's webinar, we chose some few topics for you that we've included in our agenda. So we're going to start, of course, with Industry 4.0. Then we're going to move on to Predictive Maintenance 4.0. Then we're going to talk about the evolution of inspection. And finally, we're going to move on to more concrete things, which are a live demo and an open discussion. So yes, Industry 4.0. Now let us back up for a second. So what is Industry 4.0? One of the big buzzwords flying around. I'm sure that everyone have heard about it. You might be reading about it in different sources. Probably you've attended other events talking solely on this concept of Industry 4.0. It is recognized as the fourth industrial revolution, which is the one all of us are already living in. This includes smart factories, distribution centers, and as a society, all of us are affected by these processes. So the revolution came with key trends, transformative technologies. Of course, we won't tackle all of them, but we would like to focus on key ones to orient our discussion today, like the emergence of cloud computing, robotics, augmented reality, additive manufacturing, Internet of Things, which is of high interest of our discussion today. Big data analytics as well. It's one of the important and highly interesting topics for today's discussion. So at the moment, this fourth industrial revolution sees smart factories with connected machines and intelligent robots. But how do we get there? That's the real question. How can we get there? So probably let's get us back to when it all started and look up our history. So it all started in the first industrial revolution, basically in the years of 1770s, where we moved from hands to machines, from farms to the first factories using steam and water power. Then 100 years later, electricity arrived, and the next industrial revolution. So this gave us automation. It gave us also assembly lines. You all like know about the invention of Ford, and so these were the real start of factories as we know them today. Then another 100 years later, we have the computer that has arrived around 1970s. So we now have computers that would allow us to automate some of the blue collar work in factories. We have also electronics with them, which was of high importance. And this latest industrial revolution, which has just started, which we refer to Industry 4.0, is now looking, it's not only looking at these individual computerized machines, but it's more really about this, I would say, entire ecosystem, this whole network of them, how information is flying between different systems and getting into one source. And as you know, it's not only the fourth industrial revolution, but it's also the second information revolution in which we're experiencing computer-enhanced communications. So within this revolution, I would say that there was another evolution. We would like here to zoom on what happened in maintenance. So throughout these years, and this is a consequence of the changes the industry knew, there were things happening in maintenance world as well. And each time a new industrial trend appeared, maintenance had to deal with new forms, I would say, or types of maintenance. And it all started with the first form of maintenance, which we call repair work. And here the main question was about what is happening. We were trying to examine and try to understand what happened. And the question, or the action, I would say, is about like broken damages, or when something broke, we needed to fix it right away. The main focus was on this. Then we moved to another form of it, which is time-based maintenance. Here, the approach changed a little bit, and it's more a descriptive type of maintenance in which the main question is what has happened. We were trying like to know what really happened and made these results that we have in front of us. And the actions here were about scheduling overalls. We had big but slow computers, and a lot of like I would say efforts were towards work planning and trying to I would say install some kind of control in the system. Then after that, we move into the third type or form of maintenance, and I think most of you still have it in their plans. We're having it like in many sites and industries today. It's what we call condition-based maintenance, which is based mostly on a diagnostic-based type of approach, where the question is more about why did it happen. We're trying to dig deeper. We try to analyze, trying to understand what happened. And here the action was about design for reliability. We're using different systems for condition monitoring. We're seeing new concepts like the FMCAs. We're having more expert systems. We're going towards more of multi-skilling. Then the final form of maintenance, I would say the most mature form of maintenance that everyone is looking to achieve is what we call reactive or corrective maintenance, predictive maintenance 4.0. And here the key question is about what is going to happen. We're really questioning what's going to happen tomorrow and in the future. And here the key questions are about, or I would say the actions are focused on installing or having some kind of risk-based asset management approach. We're working towards eliminating totally all types of defects in order to achieve longer useful lives. So during this evolution of maintenance, there were different types of challenges in each stage or each step. At first, the main challenge was about execution. Then we moved into trying to install some kind of standardization, and we had a lot of challenges around having some kind of quality control. Then we moved into having, or the main focus was around, the main challenge I would say was around planning and scheduling, to finally have an inspection as a challenge, which is the key topic of today's event. So it is a challenge because when we say inspection, it means I would say having readouts, having data collected from different sources. It could be manual data coming from inspectors. It could be readouts coming from different instruments and tools we're using, interacting with a digital platform, an ecosystem of software solutions, and how we can like take all this data in one place in order to apply on it advanced algorithms, advanced processing to get the real value, the real insights out of it. So yes, inspection as well evolved. It started with its first version, which is about visual, I would say it's a visual inspection, and it is about periodic physical inspections. And here the conclusions were based solely on inspectors' expertise. Then we moved into a second level, which is instrument inspections. And here, it is mainly a periodic form of inspection, and the conclusions were based on, I would say, a combination of inspectors' expertise and instrument readouts. Then the third level, which is real-time condition monitoring, which is a level that is of interest of most industrials. Here, we're talking about continuous real-time monitoring of assets with alerts given based on some pre-established rules, critical levels, thresholds, of course, that were taken from different standards. And finally, the last level, the most advanced one, is what we call PDM 4.0, Predictive Maintenance 4.0, which is about continuous real-time monitoring of assets. So here, the system is able to send alerts that are sent based on predictive techniques, such as regression analysis, for instance, and the inspector is receiving the alert and deciding on the action to take. So if we just pause for a minute and think about this little evolution here, what is, I would say, alarming and what is really interesting is that first it started with a system 100% relying on the inspector or the inspector's expertise. And then I would say it's moving into a system in which the inspector is having a different type of role, in which he's getting readouts, I would say, or output from the system and trying to decide on the action to take. In the instrument inspection type, it's a 50-50%, I would say, shared responsibility. We have the inspector that is using the instrument, so it's shared. Then in the real-time condition monitoring, it's more the inspector having a higher level of supervision of the system. And now we're going towards a more independent system, but of course, we believe that the human wear or the human expertise will still be needed in there as well. And it is of high importance. And since we're talking about the role of inspectors and how it evolved, I would like to make you think with me about the question that companies need to ask, and saying that how our companies are placed to make the step towards this predictive maintenance. So for skills, premature stages of inspection only needed experimented craftsmen. Then it moved into trained inspectors. And after that, into condition-based maintenance, where there was a need for reliability engineers. And today, it's totally different. Here, the need is really on creating some kind of, I would say, special synergy, combination of forces in terms of skills between reliability engineers and data scientists. And the main idea here is that successful implementation of predictive maintenance requires different capabilities in different or several domains. And to be, why this is to be basically on par with the concerned level of maturity. So within organizational structures, things changed. They need to make sure that their structure, their skills, their capabilities, also their incentives, etc., supported this improvement and works towards this improvement. So yeah. I think enough talking about theoretical stuff. I think it is time to probably try to move into more concrete things. What I'm having here in this slide is some kind of ecosystem that we're trying to use as our use case. It's a system that we already have installed in different sites for different clients. What you can see here is different types of machines in which we have different types of inspection tools installed in them to get like data. As we were talking earlier about the idea of computerized machines we have today in factories, this whole network of them, they are talking to each other. We have intelligent factories, of course, and the underlying technologies of Internet of Things. We have smart machines, have sensors in them that are connected to networks and talk to each other so they can diagnose their own problems and alert someone that something is going wrong within the machines. We have also big data. So all of these machines generating huge volumes of data that we can now use and analyze. And we can use things like artificial intelligence and machine learning to make sense out of this data. So we get things like predictive maintenance and smart inspection. So what we see here, just going back to I would say the left side of the slide, we're having different machines, different solutions. The first one is a solution that we call MobiVib. It's a mobile application that you can have on a mobile phone or on a tablet that is attached to an accelerometer that can help the inspector in order to acquire manual data, I would say. The version we're having today is for vibration data. It could be also used by the inspector during manual turnarounds in order to get the vibration data, of course, and also to log the audio and visual controls. Then we're having different solutions, I would say sensors, different types of sensors, wireless vibration sensors. We're focusing today on the Phantom suite of solution provided by our partner Airbus Instruments. Then there are other types of sensors other than vibration, such as the ones provided by Phantom. We can use like sensors, for current data, humidity, temperature, gas, etc. It really depends on the industry and the sector in which we're trying to put in place this system. And there is another solution that we're including here is the VBox solution. It's a wired solution that we use for automatic acquisitions also here for vibration. As I was saying before, all this data, getting it from different sources. It could be like from mobile applications, wired sensors, wireless sensors. Everything is stored in a database for further processing, classification, applying on it advanced algorithms of machine learning, of optimization, and of course, the end result here is to get visualizations. This is where we all going. This is what we want to have at the end. Are like I would say big dashboards, interesting ones with key KPIs in which I can visualize everything, and that makes my decision making more and more easier. One last point before handing the talk to Shaheen for the live demos. The system is interesting because it doesn't only include like the inspection part or the instrumentation part, but it also we're having like digital platforms that are interoperable in the meaning that it allows easily interfacing with different systems. It could be like systems in the SCADA level. We're gonna see in a little bit that the Airbus sensors, be it Phantom Suite or other types of sensors, now support the Modbus TCP/IP protocol of communication, meaning that it can allow an easy interconnection with the lower level, and also like digital platforms that allow also interconnection with higher levels, such as ERP systems you already have in place, CMMSs, etc. So I think that was it for me. I think it is right time to hand over to Shaheen. Shaheen?
So yeah, thank you, Sarah, for this presentation of this really consistent presentation. Yeah. So we're just gonna dig right into it. The first thing that we will start with is the first product here, which is quite interesting, which is the EI Wiser 3X.
It's a quick just connection. Sorry for that. I just need to unmute the laptop. Yeah.
Okay.
Can you try now?
Yeah. I think it's all good now.
Sorry. Go ahead.
Yeah. So yeah, as I was saying before, so the EI Wiser 3X, which is basically a wireless 3-axis accelerometer that has like many functionalities, and one of the main most powerful ones are its the ability to connect via Wi-Fi. So you can easily use like your tablet or PC. You can also, which is quite interesting, use like your mobile phone for acquisition. So this sensor here just enables you to do some offline acquisitions. Like really simply, you can sync your data to your local database, and also if you would like to, you can have the cloud-based platform to visualize all the data. And another functionality here is it has another extension channel, which you can really use to really just plug in and put on your tachometer, and this really just allows you to have like some on the spot, easy to use balancing operations, and also some advanced acquisition. So this is like for the lower part, or for the part where you need inspection or inspectors to go and collect data, like some route based protocol. But one of the key possibilities, the key features that allows us that the whole solution or the whole ecosystem offers is the online monitoring. So here we have just like a bunch of, or a whole lot of sensors. So there are different modules you can connect to your sensor. It really doesn't matter which type of sensor. So it could be vibration, temperature. I don't know if you need like some current, some voltage inputs. It can all be interfaced with all these modules, and also you can use also the phantom suite of sensors, which are basically vibration and temperature sensors that we have here, like a large set of possibilities you can use. So we have, for example, this orange one. It's the high frequency one. We have some low sensitivity and high sensitivity sensors. So the idea here is that you could have a full package for every use case you can have. So basically how all this works. Okay, so how all this works? It just works with the Bluetooth, the BT 5.0 technology. So you just need the one gateway or a set of gateways that you can use together to have your own BT 5.0 network. And each gateway can work as a gateway or as a repeater. And the thing is that you could have all your data up in one local database or your local network, as well as you could use the AI analytics platform, which is a cloud-based platform that gives you more and more capabilities to use your data. And another key thing, or another key functionality, is that all these softwares that we can use here, and then you can see here, for example, this is the DGY NX. It's a really powerful one, and can allow you to do like some advanced analytics or analysis for your data. And all this data can be easily like accessed, and you can do that either by APIs or direct access to the database. And this is really the use case that we work on. We try to implement all these solutions in one ecosystem, so we can have a full and a good look to monitor our assets. This is like the purpose of all this work. So, for example, here this is the iSense platform that I'm going to show you here, and it has many functionalities. One of which is to keep track of your alarm if there are any problematic assets or measurements. And Also, you can do here some really advanced spectrum analysis and vibration analysis. And one thing here is that you can add another layer of machine learning in the AI layer. So you can really have here like some helping methods that helping algorithms that will try to tell you where would if there is a problem with your asset, and what is really the source of your problem. And also there is a part of some there is a part for the forecast measurements that we can use here. So to have a view or a global view on our asset health and our asset remaining time. So since the idea here is just to to collect all the data from different sources, and also to have all this in just one simple dashboards that you can use and have most value out of. So this is here we have some we have here the dashboarding part where there is quite a lot of dashboard of KPIs you can use, so to keep track of your asset health. And the thing is here is that these dashboards are really customizable, and you can really choose what you want to see, what interests you the most. So I think this is more like one way of seeing things on how you can have all these products used to have like one larger ecosystem that will help you to step up your game and to achieve really good reliability. And I think our partner here, represented by David, will have like more things to say about this topic.
Okay, thank you so much, Shaheen. Thank you very much for the demonstrations. It was mainly about the Phantom suite of solutions and also other sensors provided by Airbus Instruments. But it wasn't these are not the only solutions we use from them. This leads us to the next part of the webinar, where I'm going to hand on to David to talk about other inspection tools. It's going to be more like about the holistic approach to asset health management, where all of the Airbus products fit together to achieve reliability. So, David, the floor is yours.
Unmute. All right, excellent. Thank you for having me. I appreciate it. My name is Dave Howard. Can everyone hear me? Can anyone hear me? All right, excellent. Thank you. So yes, my name is David Howard. I am the CEO of Airbus Instruments and one of the founders. And I will be popping up my screen here just in a second. From beginning, there we go. And let me ask Sarah for permission here. Bear with me, everyone. Not much of a Zoom guy. Let's see, share screen. And I'm ready when you guys are. Sarah, can you see my screen? All right, excellent, excellent. So yes, my name is Dave Howard. I'm the CEO at Airbus Instruments. Just a quick, I guess, about me. This is what the marketing people put in. So I have a doctorate in engineering management and data analytics. My master's is in organizational management, a bachelor's in engineering, as well as engineering leadership, associate of science and engineering technology. I've been doing this for 25 years. This is pretty much the only job I've ever had, is being a reliability professional. So former vibration analyst in the United States military, and then a reliability engineer for GE, a combustion engineer for GE, maintenance manager for GE, plant manager for a division of GE, and then director of engineering for Comtest Instruments, which was a competitor of Airbus Instruments that was acquired by GE. So when that happened, I decided that I was done working for other people, and we started Airbus Instruments. We're a privately held company. There's 3 owners, myself, Dr. Thierry Airbest, and my wife, Meg. We're an ISO 9001 manufacturer headquartered in New York, and we have 5 facilities around the world. We primarily focus on working with our partners like OCP Maintenance. We actually prefer to focus on designing and developing innovative technologies that help improve machine reliability, and then let our partners work locally with their customers as our authorized sales partner. So I'm just going to go through a little bit of kind of what is an asset and why this stuff is important. Something valuable that's owned, that's Webster's Dictionary. So we all, or most of us, own a car of some sort, a vehicle, a car, a motorcycle, whatever it might be. What's important is that we want to maintain our assets, whether it's our car that we own personally or the assets that our companies own. Otherwise, the consequences of failure can be quite expensive. So in the world of reliability, when you think about a vehicle, most everything on a vehicle we were taught as we were, growing up and learning how to drive and things, they're all time-based. So you get your oil changed every 3,000 miles. You rotate your tires every 10,000 miles. Those are time-based activities. Whereas on your car, there's also a lot of condition-based monitoring, like the ABS sensor system for safety purposes, and the thermostat for checking to make sure that you're not overheating your engine, and so on. So even in the world of vehicles, we've taken a leap, as Sarah pointed out earlier, from Industry 2.0 to Industry 3.0, but we're not quite to Industry 4.0 when we talk about our vehicles. Some of the vehicles are getting much smarter, but we're not quite there. And the reason why it's so important to focus on this Industry 4.0 is because Industry 4.0 identifies defects here in the failure curve, at the top of the P to F curve. And what that really does is that gives us the opportunity to mitigate our time, money, and risk. So when a piece of equipment fails in a predictive maintenance or preventive maintenance strategy, it's typically in this lower quadrant where there's more time, more money, and more risk associated with failure. I'll get to these questions. I just saw a question pop up. We'll talk in a second, Kareem, about that. Let me get back to this. Sorry, folks. So that's kind of the philosophy. What we want to do is we want to get to the point to where we are actually maintaining our assets where there is as little time to repair, as little risk of failure in terms of the cost of failure, or environmental risk or safety risk or things like that, and as little cost. So the less time, money, and risk, the better we're taking care of our assets. Now this P to F curve can be as long as we want it to be, because the horizontal axis represents time. So if we think about it, the more we focus on maintaining our assets, and the more we deploy the right technologies to maintain those assets and monitor those assets, the less time, money, and risk will be associated with a failure, and we are able to extend the life of our assets. And that's when we talk about extending the life of our assets, that's when we get into, come on, next slide, here we go, where we have to understand, okay, is our vehicle really any different than the manufacturing plants we work in? Not really, because in a manufacturing plant, we use various non-destructive testing techniques like ultrasonic thickness, airborne ultrasound, vibration analysis, infrared thermography, oil particulate analysis, and analytical ferrography. Those things are all valuable tools that we can deploy in a plant, but we could also deploy those in our vehicles. The reality of it is that most people don't deploy those technologies on their vehicles. So how can we be more reliable? Well, there's a lot of studies out there. I've been a member of a number of professional boards over the years, and been a member of a number of working committees through the SMRP and other professional societies. And we've done a lot of benchmark work. And really what it comes down to is The goal is to have at least 80% of your workflow focused on preventive maintenance, predictive maintenance, condition-based monitoring, proactive, planned and scheduled activities. So firefighting is something that's not ideal, because that firefighting, waiting for something to fail and then fixing it, is what costs so much more time, money, and risk. So what really is proactive? We want to be proactive by having the right foundation in place. Everything from having the correct installed capability of our manufacturing facility, having everything documented correctly, making sure that we're efficient and effective in our procurement, operations, and maintenance skills activities. And then that builds the foundation for strong asset health. And when you have strong asset health, you have high asset utilization and low maintenance cost as a percentage of your replacement asset value. So we'll get into these basic terms. Breakdown: you're running to fail. Preventive, you're doing something interval-based every 3,000 miles. Predictive, you're doing something where you're using data to drive your decisions. And then reliability-centered or proactive is where you're using the correct mix of preventive, predictive, and even at times run-to-failure strategies. So that's where we really need to focus, is getting to that reliability-centered proactive domain. That's Industry 4.0. One of the key measurements is overall equipment effectiveness. And to calculate OEE, we take our availability rate and we multiply that by our performance rate, and then multiply that by the quality rate. That gives us our demonstrated capacity, but that's not our design capacity. So we always have to compare, as a manufacturing organization, our design capacity. What did we originally design this manufacturing facility to operate at, whether it's 400 metric tons of titanium dioxide per day, or it's 3,000 board feet of 2x4s generated by the sawmill every hour. So there's lots of different things that we need to consider, but measuring OEE is the first step, because we can compare that to our designed capacity. So at Airbus Instruments, we focused on a very holistic approach to condition-based monitoring, integrated approach to asset health management. And how we did that is we look at things like, hey, when you have a manufacturing facility and you have unscheduled downtime, scheduled downtime, operations losses and process slowdowns, or out of spec product that you've manufactured, if it doesn't meet your quality spec, those are all losses. Those are all losses in your existing design capacity. So by being able to identify those loss opportunities, we're able to then attack those loss opportunities and work toward achieving our design capacity, along with our design quality specifications, along with our design maintenance schedules. That's finding your hidden plant. Most people are not operating at their full design capacity. And this is, I wish I could take this myself and say that I created this, but this is actually from John Mitchell. He's a world-renowned author in the field of reliability-centered maintenance. So let's look at this data. There's data. No, I'm going to actually skip through this, but I'll show you very quickly. If we look at this particular facility working on moving from reactive to proactive, or working from reactive toward Industry 4.0. This one facility went from 55% reactive to 50% to 50%. They were focusing 30% of their time on preventive maintenance, 25% on preventive maintenance, increased their PDM to 15%, which is really not a lot. But boy, I'll tell you what, it lost them $5.3 billion in lost production over 12 years. And this is like realistic, very realistic data. This is independent data. This isn't data that, we dream up. This is data from the Electric Power Research Institute, or SMRP, or the Vibration Institute. So you look at this one, cost of maintenance, run to failure maintenance in terms of dollars, US dollars per horsepower per year. Look at how much it costs, almost $18 per horsepower per year for an asset to maintain in a run to failure strategy. So that's, that's industry 1.0, 2.0, 3.0, 4.0. So we're over here at industry 4.0. What does it cost? $4 per horsepower per asset to maintain your asset. That's why we do this. That's why at Airbus Instruments, we did what we did with Phantom and the rest of our product line. But PDM is not going to replace PM. PDM is going to strike the balance. 89% of our equipment, if you look at the RCM curves that are available from the original Nolan and Heap study, what you'll find is that 11% of your assets are age-related failures. 11%, that's the average. So is a preventive maintenance strategy the right strategy for all of your assets? No, it's not. A predictive maintenance strategy using technology like Phantom and sensor technology and analytical technology, that actually applies to 89% of the rotating equipment in your facilities. So why are we focusing so many man hours on preventive maintenance still? So the vast majority of PMs can also be replaced by PDM. So that's where a lot of organizations look at it and they say, well, I can't afford to do PDM. I can't afford to go to Industry 4.0. But can you afford not to? Because if you think about it, in this particular study from 2005 with the SMRP, what we found is that of the number of tasks, literally a wide variety of them, total number of tasks, 20,000. 5,876 of them were non-value added. They were not an actual measurable inspection. So you had a PM written in your CMMS system that said, go out and check this motor, go look at this. But it doesn't say, it did not say, go look at this and tell me what the temperature is, what this is. There's no quantifiable measurement. So then you look at it and you say, of those 20,000, 6,437 of them could be replaced with predictive condition-based monitoring. 5,200 of them could be re-engineered using a FMECA, a failure modes and effects analysis. And then only of the 20,000 RPM or 20,000 PMs in this particular plant, only 2,487 of them were actually valuable as written, meaning they were quantifiable. They could not be replaced with PDM. They could not be re-engineered with FMEA. There was no modifications that were required. So what that really tells us is if we focus our activities on PDM activities, replacing those non-value added preventive maintenance tasks with PDM, we can actually free up our maintenance staff to do other important tasks. Like those guys can now be working on a capital project to expand our design capacity. There's so much more we can do with our people if we focus on using the technology to be efficient. So let's look at, this is also from the SMRP. And if we look at the percent of, percent of assets that are being monitored with various predictive maintenance technologies. So vibration analysis coverage in a top quartile plant where they're manufacturing, top tier, their costs are down, their quality is great, they have very little safety incidents. Those types of organizations are measuring of the assets that could be monitored with vibration analysis, 88% of them are being monitored. With the assets that could be monitored with infrared technology, 79% of them are being monitored. That's the reality of it. So we can look at it and we can say, okay, top tier performance, what does it look like? But then what does that top tier performance get the organization? It gets you that $5.2 billion over 12 years that we saw in the slide earlier. So what did we do at Airbus is we focused on the big three. So vibration, balancing, and alignment represent 45% of predictive maintenance analysis and condition-based monitoring and online monitoring opportunities. So if we look at all the failures and all the condition-based monitoring technologies that are out there, and then we say, okay, of the failures, going through a root cause failure analysis, going through a failure modes and effects analysis, when we go through those, we found that 45% of all the failures that were studied, which were tremendous, over 1 million failures across numerous industries, vibration, balancing and alignment represented the root cause of 45% of those failures. So that's where we focused as a company, is starting off with making sure that we have an excellent vibration analysis platform, an excellent balancing platform, and an excellent alignment platform. And then we worked on the other things. So here's some examples. This is a benchmark where this particular facility, 2015, their technology credit for return, vibration, 35% credit on return, a 16-to-1 return on investment by deploying PDM. So if we look at it and we say, okay, well, when they were doing maintenance strategies by percent, 7% run to failure strategy, 29% time-based preventive maintenance, and 64%, 55 plus 9, 64% of this organization with a 16-to-1 return on their investment was focused on industry 3.0 and 4.0, predictive analytics. So the data supports the decision itself. That's just one particular study. Now we look at another one. This is a steel facility, actually not even a facility. This is one of the largest steel manufacturers in the world, 18-to-1 return on investment, with 50% of their time focused on industry 3.0 and 4.0, preventive maintenance, predictive. So you look at the predictive, 48%, proactive, industry 4.0, which is condition-based analytics, 50% of the time they're focused on the right activities. So it's the return on investment, they're spending their time on the right activities. That's really what it comes down to. Paper industry, 19-to-1 return on investment, 62% of their time focused on working within the industry 3.0 and 4.0 domains. So this is where the rubber hits the road, and this is where it gets really interesting. I'm going to show you different industries, but let's use the chemical industry as our benchmark. Okay, so the percent of assets in a top tier chemical manufacturing facility that they are monitoring with vibration analysis, 88.5% of the assets that could be monitored are monitored. 71% for infrared mechanical, 100% for infrared electrical, 38% for oil analysis, and so on. What does that really mean though? Look at the cost of maintenance as a percentage of the replacement asset value. So if you have a $100 million facility, that's how much it costs you to build a $100 million facility, or this manufacturing facility. We'll say it's $100 million. That means this manufacturing plant, this manufacturing plant that's doing everything right is actually, it only costs them $1.4 million to maintain that facility on an annual basis. Well, let's compare that to the facility that is not doing hardly any vibration analysis, infrared, or any of these industry 4.0 technologies. Well, it's quite clear, 17.3% as of their replacement asset value. So that means their maintenance budget is $17.3 million per year. And that's the reality of it, guys. That's why we're focusing on what we focus on. And that's why we're here today, is by deploying industry 3.0 and 4.0 technologies, we're actually able to achieve a lower cost of maintenance, lower cost of operation, and a much higher level of asset reliability. So we focus on the big three: vibration, alignment, and balancing. And then we worked on some other organization or some other technologies. So we're focused on continuous improvement. I went through a couple of these case studies. I don't want to dig into them much. Our aspiration as a company is we are the masters of machine health. So we aspire to be the Google of the predictive maintenance industry. I would argue with any other CEO in this space, and say that we will focus on innovation and commit to innovation more than any other company, because we've released more new products that are functional, that add value, and that actually customers are using on a daily basis in the past 3 years than any of our competitors. So Digivibe is our portable system. It's the brains of the operation. It's the software. Wiser is for route-based data collection. Phantom is a whole entire suite of wireless sensor technology, because let's face it, vibration is not the only technology. It is important and it is helpful, but there's so many other variables that we need to consider, like amperage, pressure, flow, temperature. There's just oil, particulate. There's so many things that we need to consider that we created Phantom to be an entire ecosystem. The EI Shaft Ace is our laser shaft alignment product. The EI series is where the company started. We started 35 years ago as a balancing machine company, and we built this company over the past 11 years, my cousin, my wife, and I, into what we are today. One of the newer products that we released is actually very exciting. It's called video deflection technology. It's a product that allows the user to use any one of their cameras. You can use the camera in your mobile phone to record a video in slow motion and then post-process it in Dragon Vision and perform a video deflection model, similar to ODS, but using a video. And what that does is it gives our managers and all of the folks that are in our world of senior management that don't understand the squiggly lines of vibration analysis, it gives them a way to visualize the problems, much like the dashboards that Sarah and her colleagues were showing earlier. So we have 5 facilities, 2 in Mexico City, 1 in Glens Falls, New York, where our headquarters is, 1 over in the UK, and then 1 in Canada. And I fully expect that we'll be operating with hopefully a Middle East office in the next couple of years. Not that that's going to affect any of our partnerships. It's more to just have a local application engineer in the Middle East to support our products and support our partners. So as I said, we have distributors all over the world. We are very proud to partner with OCP Maintenance Solutions. They have been a great partner, and we believe that they have the right footprint to be able to give our customers the best service in the North Africa and Morocco regions. So this is our ecosystem, and I won't get into a lot of detail, but I'm just going to draw a line of delineation here. So over here, we have Phantom. Whether they're vibration, temperature, amperage, pressure, flow, it doesn't matter. Phantom communicate via Bluetooth Low Energy 5.0 encrypted technology to the gateways. The gateways then communicate via either Wi-Fi, Ethernet, or LTE to either a local server or a cloud server. The great thing about Phantom that I think makes it unique and is worth noting is Phantom is, it's my favorite superhero. Okay, so this is where I'm the geek in the room, and I'm going to say, hey, my favorite superhero is Wolverine. Wolverine's self-healing, right? So if you think about it, Phantom is much the same. Phantom was named after the first aircraft I ever worked on in the Air Force. It was the F-4 Phantom. It was the most difficult airplane I ever worked on, but in reality, taught me a very valuable lesson. The Phantom was also, in terms of difficult to work on, it was also one of the only aircraft that had so much redundancy that it was considered a self-healing aircraft. If you blew off the outer 3 feet of the wing, guess what? The aircraft would still land because we had secondary and tertiary hydraulics. So much in the same regard with Phantom, it's a self-healing network. So if this sensor cannot connect to the gateway, it's going to look at another sensor or another gateway and hop its signal across so that we don't ever lose data. That's unique. That's unique in the wireless industry. Mesh networking technology has not been successfully deployed by any other manufacturer that I'm aware of in the wireless sensor IoT space. And then to take that technology and also make sure that it's secure, which is the key, that's where we need to, you know, we could do a whole nother webinar on wireless security. Anytime, Sarah, just let me know. Anyways, self-healing network, sensors communicate to the gateways or other sensors. They communicate to a local server. They all have Modbus TCP/IP built into them, so we can communicate with our DCS and our SCADA systems and iHistorian and things like that. Phantom also has an API where, you know, our partners like OCP are creating their own visualization tools to help customers understand what's going on with their assets. Digivibe MX is the brains. That's the analytical software that does all the trending and reports and analysis. The portable solution is Wiser. So the portable route-based data collection and spot checking and things like that, that all happens, goes to the cloud or goes to a local server. Digivibe connects to either for analysis, reporting, and trending, and they all connect with Modbus TCP/IP so that we can partner with our operational counterparts. So let's see, stop annotating. How do I do that again? Go mouse, clear, and stop. Hold on just a second, sorry. Clear all, there we go. So one of the things that's unique about Phantom, and I think one of our greatest achievements, is the fact that we can push that data, those live notifications, directly to the user. So if you're in the field and you have a problem with a machine, not only can you take data directly from your phone and look at it, but you'll also receive all the alarms and notifications directly on your phone. And that's something unique, because now we're able to tie our operations partners as well as our maintenance partners on the shop floor to the data and make actionable decisions. Clear all X. There we go. Oh, sorry. So, and then to take it a step further with Phantom, with Erebus Instruments, we have our own, you know, EI Analytic Cloud capability. And what that does is that gives our customers a very quick, holistic look at the bad actors in their facility. So these are the pieces of equipment that are in the worst state of alarm. And then these are the pieces of equipment that are in the highest rate of asset health decline, meaning they are failing the fastest. And that's using our own, you know, machine learning algorithms that we've created to be able to calculate these things. Asset health, just a quick overview and a quick look at, you know, what's going on with our facilities. Then looking at, you know, all of the sensors. We always know every 5 seconds, each sensor's battery, temperature, signal strength, and overall velocity RMS. Couple more screens. This is where it gets exciting, because most of you don't know this, but one of the things that we identified is we solve problems. So when we go out and we do infrared thermography in a facility, one of the biggest problems is that you have to wear all of the arc flash protection when you open up that high voltage switchgear. Most oftentimes, it's 2 men working in the field, collecting the data with their arc flash protection on, and that infrared camera. So now you have a very expensive infrared camera. You also have, on top of that, two technicians working to collect data on a, let's just say, monthly basis. Now, in reality, most facilities don't do infrared routes monthly. They do them semi-annually, quarterly, or annually, because it is so costly to do, both in time as well as the man hours and the technology, the actual camera itself. The alternative to wearing the arc flash protection is infrared windows. Well, infrared windows are great, but they're also expensive and they require you to be intrusive. You have to cut a hole in your switchgear and install the window. You can only do that during a down period when the switchgear is not energized. So it's a problem if you want to monitor your electrical assets. So we created Phantom IR. Phantom IR, we're really excited to release. In fact, this webinar is where we're officially releasing it. That Phantom IR module right there is a $300 module that can be installed inside of a switchgear. So now it's installed inside of a switchgear, transmitting wirelessly to the gateway on the wall what the infrared signature is, so that we can do basic spot checking of our critical assets, our critical electrical assets mostly. And then the other thing that is not as new, but certainly exciting to announce, we are also releasing our own phantom oil monitoring sensor. So this sensor, combined with our GP sensor, allows us to monitor both the coarse and the fine particulate ferrous metal within an oil sump. So if you have a critical oil sump in your facility, we can actually monitor that in real time. As far as who we work with, I'll just finish up with this. We are a global company with, I mean, customers in just about every industry, whether it's automotive, food, government, technology, aerospace, mining, steel, education. We've been doing this for a long time. So in fact, I need to update this because there's a heck of a lot more than other big names that I'd like to add to it. So, but we work with customers big and small. So doesn't really matter. We're happy to be here, and we're happy to be partnering with the folks at OCP. And I hope that this was not too much of me rambling on. So if you have any questions, I'm happy to answer.
Thank you very much, David. Thank you for the great presentation, for all the information you shared with us and with our audience. We have a lot of questions.
Sure.
So I don't think we will be able to go over all of them, but I'm just gonna pick a few of them.
Sure.
I will shoot the first one to you, David. What do you think about this?
That's fine.
Okay, so the first question is saying, do you use FMCW radars as sensors for monitoring machines' vibration?
No. No, we don't.
Okay, short no.
That's an easy one.
Okay, great then. Okay, so I'm having another question. So it's saying, what are the risks of an Industry 4.0 solution? So probably you can start, David. I'm going to give another answer in French, probably for our French community. So,
sure.
Okay, so go
ahead. The biggest risk with Industry 4.0 is not being educated, not understanding the security aspects. There's a lot of products out there. And if we look at what happened at Colonial Pipeline recently here in the United States, that hackers took over the entire pipeline for the eastern coast of the United States. And that's very dangerous. And there's a lot of reasons why that happened, but one of the reasons that happened is unsecure networking, or insecure. So Airbus takes that very seriously, and I think we're the only Industry 4.0 solution provider that actually has our own. Each of our sensors have their own integrated cryptographic coprocessor. So the data that's being sent from the sensor to the gateway is encrypted. And the only way to get that data decrypted is either using our API with our instructions, or by using our software and our dev key, our app key, and our net key. Those are all critical elements that we need to consider.
Okay. Thank you so much for the answer, David. I join you in the aspect of security. I think it's a very important one. I'm gonna just switch here to French, just to probably motivate our community and our attendees to send us their concerns, their questions, so we can have a French discussion as well. Alors oui, effectivement, comme vient de le mentionner David, la sécurité, c'est un aspect qui est très important. C'est un risque de l'industrie 4.0, des solutions de l'industrie 4.0. D'ailleurs, c'est une question qui vient toujours de nos clients, que ce soit pour les capteurs, comment, je dirais, faire la communication entre le hardware et le software, ainsi de suite. Alors, parlons du risque de l'industrie 4.0. Vraiment, c'est dans l'approche, je dirais, dans le sens où elle peut devenir caduque, bien sûr, dans le cas où elle n'est pas bien analysée. Alors, on risque de faire un investissement important sur des solutions qui ne sont pas évolutives. C'est vraiment un sérieux problème de se trouver devant un système legacy system, qui est un petit peu loqué. Et c'est un point bloquant parce que l'évolution du système, l'aspect de sécurité, l'aspect d'interconnexion, l'aspect d'avoir des solutions open source dans le sens où on a les API qui sont déjà dans le public domain, je dirais, c'est très important. Alors, tout ça est contre la philosophie de ces plateformes digitales qu'on essaie d'instaurer pour avoir un seul écosystème. Et aussi, on ne peut pas revenir en arrière. Alors, si on a une stratégie 4.0, je pense, ben là, c'est bon, vu que cette stratégie impactera profondément toutes les autres activités industrielles de l'entreprise. Alors, c'est ça pour la question. J'espère que j'ai répondu. I'm seeing here more questions, David. So I'm going to pick the next one. So they're saying how the data accuracy is challenged to overcome bias in decision making.
Sorry, run that by me one more time.
Yeah, how the data accuracy is challenged to overcome bias in decision making.
So one of the reasons that we created a whole suite of sensors was because squiggly lines, and I'll say it like that because most people don't understand vibration analysis, but especially in senior management and plant management and things, visualizing the data and telling a story of the machine's health is what really drives decisions. The spectrum in the FFT and the infrared thermography image or the analytical ferrography report, those things don't tell a manager when they need to make a decision. It's being able to take that data and represent that data so that the customer can make, or the end user can make, a decision based on the data. So when people challenge the data, it's more important to understand the data behind the visualization. So if you're going to visualize the data for a customer and the customer says, well, I'm going to challenge that because I don't believe that, then you have to be able to understand the data behind the visualization. And that's where Airbus does a very good job of that with Phantom, as well as all of our other products, because all of that data that actually drove the decision or drove the visualization, the raw data belongs to you. We're not hiding any of that raw data. It's your raw data. You can do with it however you want to do with it. It's not we don't encrypt it. We don't hide our database architecture. That's the key, is having that raw data to understand how it's visualized, so that you can back up anyone who may very well be questioning the visualization.
Yeah, I totally agree. Thank you for the info. Just a quick note here before going and taking the next question. I just want to tell our attendees here that we're having an issue with the namings. So can you please just send your questions to contact@ocp-ms.com, please. This way we can take out of your questions, or probably write your name first. And then send the question our way. I'm going to take the next question, and it is saying, everyone is talking about Industry 4.0, the fourth industry revolution, and how it will change the manufacturing sector. But generally, it is based on the internet network, so there is a need to migrate to 5G. This, which remains impossible for certain countries. What do you think about this, David?
Well, I don't think 5G is the only solution. And that's why we created Phantom, with the scalability of either local network using Ethernet or Wi-Fi, as well as any other internet source. In fact, we have a number of shipping vessels that use Phantom using satellite internet. So there's the data throughput of a Phantom sensor in terms of the data packet size is so minuscule that even in a 3G environment, the sensors on reasonably large deployments are able to send effectively in a 3G cellular network environment. Ideally, you want to be 4G or better, but if you don't have a 5G capability, that doesn't mean you can't deploy Phantom. It just means that there's other communications protocols you need to explore, whether it be satellite, 3G, even LoRaWAN. There's 100 different ways to skin the cat when it comes to communications. Don't ever think that 5G is something that would stop Industry 4.0, because it's not going to.
Yeah, definitely. So talking about LoRaWAN, David, so do you have anything to say about the technology? What do you think about it? Like, and what are your products that probably implement this technology?
So I can tell you that we're very actively looking into it, and I don't want to get underneath the tent too much, because we are actively pursuing and we are actively working on deploying different communication technologies and different options, because we recognize, I mean, when we came out with Phantom originally 4 years ago, it was a risky proposition. We didn't know what was going to happen, but thankfully we took the right approach, and we developed a whole ecosystem of sensors with open source architecture and very secure communications. So now we're looking at, okay, what's the next generation of communication, whether that's LoRaWAN or other options that are out there that we're exploring.
Great. Okay. So I think we're gonna take like just one or two more questions, and then probably we're gonna end this session today, and probably we might organize another one to discuss like more topics. So here, like just talking about LoRaWAN, I know that it is highly used in sectors such as smart farming and smart agriculture, and also here in OCP Maintenance Solutions, we're developing another version of the iSense platform, which we're calling AgriSense. It is for smart agriculture, where like we're using, of course, sensors using the LoRaWAN technology in order to get different types of data. It could be humidity, it could be temperature, etc. So there is also a question here in the chat box saying that first, thank you for the interesting presentation. And do you have some references in wind farm?
Oh yeah, we actually, Clipper wind turbine as well as GE wind turbines are GE offshore, not onshore, but offshore wind turbines are both using Phantom technology very actively right now. Clipper has well over 5,000 or 6,000 sensors deployed across their wind farms here in the United States.
Great, then, yeah. So I think we're having like a lot of questions coming in. As I said before, like I shared the main address, the contact at ocpms.com, where you can send us like all your different questions. I think probably we can get back to every single person and probably see if we can schedule any kind of presentations with them to talk deeply about one specific technology or specific use case. Probably, what do you think, David? Do I take one last question?
Yeah, go ahead. I've got time.
Okay, cool then. I've seen one, I think, about the shaft alignment. It was here. Yes. Yeah. So they're saying my question is about shaft alignment. Do you have a solution for shaft alignment with laser technology? If yes, what are the criteria for choosing a product and not another one?
So one of the things that, beyond just being open source and our open architecture, what we've done at Airbest Instruments is we've focused on using off-the-shelf hardware. So if you look at this mobile device in my hand, this mobile device has more horsepower, more processing capability than any of the third generation data collectors or laser alignment systems. So you look at all of the laser alignment systems on the market: Easy Laser, Proof Technic, Fixture Laser, AQM, SKF. All of those systems use a dedicated box, and that dedicated box has one job: to do shaft alignment. Well, that limits productivity. So what we did is we said, okay, well, we're going to make our laser shaft alignment system work on Android, iOS, Windows, and we're going to let the customer bring their own device if they want to. So it reduces the cost of acquisition of the equipment, and it's been wildly successful. We've done that with our lasers, with our Wisers, with Phantom, It's all meant to be multi-operating systems, so that whether you're at your desk and you want to look at data, or you're on your phone and you want to look at data, or you're on the web traveling and you want to look at data, it's all the same user experience. And the same thing applies with the laser. Our laser, in terms of what it can do everything that a top of the line rotor-line laser alignment system can do. Our VibraLaser, our shaft ace, is able to, with the, like we call it the VLSat Pro, that VLSat Pro can do machine train, horizontal, vertical, soft foot, thermal growth, every single alignment option there is. So I think the major criteria is, does the device do the job you want it to do? And is it within the price point that you want to spend? Because I can tell you that not everyone wants to spend $30,000 on a Protechnic rotor-line, but a $10,000 VibraLaser Pro system that can do all of the same tasks as that $30,000 system, they're more than happy to, because it provides a much better return on investment. So I think you have to look at your return on investment, the accuracy of the system. Does it meet your accuracy requirements? Is it easy to use? And does it meet your budget?
Perfect. Perfect. Thank you so much, David. I think now for real, we're going to take one last question before closing our session. And this question is quite different, special question. So the attendee is saying, you talked about the evolution of competencies and skill sets in organizations to make the transition to maintenance 4.0 solutions a successful one. So this means that trainings are of high importance as well as certifications. What do you think about this?
Well, I think that your organization is only as good as the people that are in it. So, you know, you can have the most amazing machinery, the most well-designed manufacturing facility, but at the end of the day, you have to invest in your people. Your people are your number one asset. So before you go buying any kind of vibration analysis equipment or Phantom or anything else, do you have the people on board, and are they I don't want to say trained, but are they at least culturally on board with the idea of transitioning to the next level of maintenance? And if they are welcoming that idea, then that's when you can start the training journey. And maybe the training journey includes some precision skills training on pump alignment, pump installation, motor alignment, motor installation for your millwrights. And then maybe that involves documentation for your planner and using SAP, and then training your engineer on RCM and FMEA. So you have to invest in your people, because the tools aren't going to do the jobs themselves.
Yeah, perfect. Actually, I really join what you just said, David, and definitely like the transition in the culture to install this system or to make it a successful one is very important, as well as like trying to get to the required skill sets to make this transformation, I would say, a successful one. And now like I would say trainings and certifications are really available. They're not like hard to get. Wide variety of I would say ones available, as you said, in specific technologies or probably in vibration analysis and so on. So yeah. So it was great. It was great having you. It was great having this discussion. Thank you so much for your time. I would like also to thank all of our attendees for their time, for their dedication, for squeezing this time for us in this Friday. And yeah, so we're having a lot of other questions. What I would suggest, I'm emphasizing on this, please do send us your questions in the email we've shared in the chat box. I'm going to share it again just in a moment. And of course, we'll definitely get back to you as soon as possible. Thank you, David. Enjoy your weekend and speak to you very soon. Same thing for our attendees. Enjoy your weekend.
Yes, everyone have a good day. Thank you.
Thank you. Bye for now. Bye.